Welcome everyone to our online course in macroeconomics. I would like to begin with a thought-provoking question from the great economist Paul Samuelson, who once asked, "Why does public discussion of economic policy so often show the abyssal ignorance of the participants? Why do I so often want to cry at what public figures, the press, and television commentators say about economic affairs?" This question captures one of the main reasons why studying macroeconomics is so important. Every day we hear debates about inflation, unemployment, taxes, interest rates, and government spending. But too often, these conversations are filled with confusion, oversimplification, or emotional arguments rather than sound economic reasoning. In this course, our goal is to move beyond opinion and learn how to think like economists. We will explore the models, data, and tools that help us understand how the overall economy and functions, how output is produced, how prices are determined, and how government and central bank policies affect growth and stability. By the end of this course, I want you to feel confident analyzing economic events for yourself, to understand why behind the headlines, to interpret economic data critically, and to separate facts from misconception. So, as we begin this journey, keep Samuelson's question in mind. The more you understand macroeconomics, the less likely you are to cry at what you hear on the news, and the more capable you will be of contributing intelligently to discussions about the policies that shape our collective future. This information highlights key economic concepts. Opportunity cost refers to the value of the next best alternative that must be given up when making a decision. It reminds us that every choice involves trade-off. The laws of supply and demand govern how prices and quantities adjust in markets when policymakers attempt to override these laws through tools like price ceiling, maximum legal prices, or price floors, minimum legal prices. The market strays back, often resulting in shortages, surpluses, or other unintended consequences. This information helps understand that trade creates mutual benefits through the law of comparative advantage. This law shows that even when party is more efficient overall, both can gain by specializing and trading. Voluntary trade ensures all participants are better off. It also emphasizes the importance of thinking at the margin, making decisions by comparing marginal costs and marginal benefits to achieve the most efficient outcomes. An externality is a cost or benefit of an economic activity that affects people who are not directly involved in the transaction. A negative externality occurs when the activity imposes a cost on others. For example, pollution from a factory. A positive externality occurs when it provides a benefit to others. For example, education improving society's productivity. In both cases, externalities cause market outcomes to be inefficient because the full social costs or benefits are not reflected in market prices. The trade-off between efficiency and equality refers to the balance society must strike between producing goods and services in the most effective way, efficiency, and distributing economic resources fairly among people, equality. Efficiency means maximizing total output and wealth. For example, getting the most from limited resources like oil. Equality means ensuring everyone shares in that wealth more evenly. However, policies that promote equality, for example, higher taxes on the rich or welfare programs, can sometimes reduce incentives to work or invest, making the economy less efficient. Other examples, for instance, when the government increases income taxes on high earners to fund social programs for low-income families, equality improves because income is redistributed. But this may reduce efficiency if higher earners work less or invest less due to lower after-tax rewards. Government policies such as fiscal and monetary policy aim to stabilize the economy through tax, spending, interest rate adjustments, but their effectiveness is not guaranteed. When the government increases spending to boost economic growth, businesses produce more and hire additional workers, reducing unemployment. However, as demand for goods and services rises, prices begin to increase, causing higher inflation. Conversely, if the government cuts spending or raises interest rates to reduce inflation, demand falls and unemployment tends to rise. This is the trade-off between inflation and unemployment. Yes, productivity growth is almost everything in the long run. For instance, over the past several decades, countries like South Korea have experienced rapid economic growth largely because of improvements in productivity through, for instance, better education, advanced technology, and more efficient production methods. This increase in productivity has raised incomes and living standards far more than simply adding more workers or working longer hours could have. Economics combines mathematical reasoning, historical analysis, and statistical methods to explain how people and societies make choices about resources and respond to incentives. In economics, we use abstraction. Abstraction is to abstract from unimportant details, which is necessary to understand the functioning of anything as complex as the economy. Yes, we do have abstraction in economics. For instance, we ignore many details so as to focus on the most important elements of a problem. Proper degree of abstraction is important and depends on the objective of the analysis. Theory is deliberate simplification of reality. It explains how relationships work. In statistical correlation, variables go up or down together. This does not, however, imply causality. Economic models simplify real-world situation using equations, graphs, or words to explain relationships. Though disagreements arise due to imperfect information and differing value judgments. Economic graphs use large quantity of data quickly and efficiently, which facilitates data interpretation and analysis. In economic graphs, we look at relationships and establish how important these statistical relationships are. Variable is always measured by a number. It analyzes what happens to the other variables when the size of that number changes. For instance, gender is a variable. Education is a variable. Economic growth or economic development is a variable. Two variable diagrams graph relationships between two main variables, with the horizontal and vertical axis meeting at the origin where both values are a zero, helping to focus on key economic relationships. Here is an example of two variable diagram that shows the relationship between quantity consumed and price. Figure 1, hypothetical demand curve for natural gas in St. Louis. As you can see, quantity demanded increases as price decreases or vice versa, indicating negative correlation between the two variables. The slope of a straight line shows how one variable changes with another. Positive slope when both variables rise together, and negative slope when one increases and the other decreases. A negative slope, for instance, the demand curve, is an example of a negative slope. As price increases, quantity demanded decreases, and vice versa. For instance, when the price of coffee rises, people buy less coffee. The supply curve is the example for a positive slope. As price increases, quantity supplied increases. For instance, as the price of wheat increases, farmers produce and sell more of wheat. A fixed cost line is an example of a zero slope. Yes, a fixed cost line is an example of a zero slope. For instance, cost stays the same regardless of output. Another example is that a fixed rent cost line. For instance, rent stays the same no matter how much a business produces, such as rent control, which is also known as a fixed rent cost line. And finally, we have the infinite slope, which is a vertical line showing a perfectly inelastic demand. Quantity demanded does not change even if the price changes. Why it makes sense? Think about slope as rise over run. A vertical line has infinite rise for zero run. As a line gets steeper and steeper, its slope increases without bound. A perfectly vertical line is the limiting case where the slope approaches infinity. Don't forget, in the infinite slope, the slope is infinite, or it approaches infinity. A real-world example. Imagine you are describing the steepness of a cliff face that goes straight up. Imagine you are describing the steepness of a cliff face that goes straight up and down. You can't express its steepness as a finite number because there is no horizontal distance traveled for any vertical distance climbed. It is infinitely steep. This is a summary of what we discussed. In zero slope, y value doesn't change. In infinite slope, x value doesn't change. The slope of a straight line has the same numerical value. This is the slope of a straight line. Measuring the slope of a straight line is straightforward. Here is how. The slope formula is established as slope m. Slope m refers to y2 minus y1 divided by x2 minus x1. Or a better expression of this is slope m refers to y sub 2 minus sub y1 divided by x sub 2 minus x sub 1. This represents rise over run. In other words, the vertical change divided by the horizontal change. So if we summarize it as a step-by-step process, identify 2 points on the line, x sub 1, y sub 1, and x sub 2 and y sub 2. Subtract the y coordinates, y sub 2 minus y sub 1, which is the rise, and subtract the x coordinates, x sub 2 minus x sub 1. This is the run. And divide rise by the run, or rise over run. We will use graphical approximation to find the slope of a curved line. So far, we have been able to measure the slope of a straight line, but the curved line is a little bit different. We use graphical approximation. If you don't know the equation, always draw a tangent line at the point of interest. Behavior of slopes in curved graphs is the same as we discussed before. Figure A establishes a negative slope. Figure B establishes a positive slope. Figure C, we have the positive and the negative slope at the same time. And in figure D, we have the negative slope and the positive slope at the same time. How do we measure the slope at a point on a curved graph? This is a little bit challenging because our graph involves a curved line as opposed to straight line. So at this point, here is what we are going to do. We will draw a tangent line at the point of interest. For instance, draw a tangent to point T and draw a tangent to point R. You need to pick 2 points on the tangent line, such as C and A, or D or F. Calculate the slope using our formula, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Here is an important note. Unlike a straight line, which has one constant slope, a curved line has different slopes at different points. Yes, here is the crucial point. A curved line has different slopes at different points. That's what makes it curved. The derivative tells you the instantaneous rate of change at each specific location along the curve. Here's a summary of what we have learned using the graphs. We have learned the y-intercept, the x-intercept, ray through origin, which is the y-intercept having a zero slope. And then we're going to show 45-degree lines, which are also rays through the origin. And it has a slope of 1 with an angle of 45 degrees. Sorry, 45 degrees, yes. Here are different rays through the origin. The blue ray has a slope 1. The one to the upward of the blue ray has slope 2. And the ray to the downward of blue ray has positive 1/2 slopes. This chapter was a simple introduction to macroeconomics. Make sure to review your notes and slides. We have covered Chapter 1. Thanks for listening to my lecture and have a good day. Bye-bye.